Welcome to Checkpoint Revision Lessons. In this lesson, we'll be considering sample paper 1, and our focus is going to be on the chemistry component. This revision as well will also be on the new curriculum, which was published in September 2020. Now, the first question we have here is to look at this diagram, which is part of the periodic table, and use it to write the electronic structure. To write the electronic structure of aluminium. To write the electronic structure of aluminium. Now, if we are to write electronic structure, we have just 2 rules that will guide us. You should know that the first shell can take a maximum of 2 electrons. The second or subsequent shell, can say next shells, will take a maximum of 8 electrons. First shell will take a maximum of 2 electrons. Next shells will take a maximum of 8 electrons. That means next, even if I have 4 shells for this class, that is what we need. The first shell can take 2 electrons, and subsequent shells can take a maximum of 8 electrons. The next thing we need to consider is to look at aluminium. Proton number is the same thing as the number of electrons. Remember that the electron is negatively charged. So proton number is the same as number of electrons for an atom. In that case, if I look at the periodic table, the atomic number of aluminium is 13. So if I'm to draw this atomic structure, what do I do? I will draw a first shell. Can it take 2? 1, 2. So, but out of 13, I've used 2. So that means I can still have another shell. The next shell can take a maximum of 8. So I can do 1, 2, 3, 4, 5, 6, 7, 8. I've used 10 out of the 13 electrons. That means it can still accommodate more. It cannot accommodate more. I have to move to the next shell. That's 1, 2, 3. But the instruction is to write. So all I need to do is write it. 2, 8, I can put a dot or a comma. 2, 8, 3. Then the next question is, how many protons are in an atom of fluorine? How many protons are in an atom of fluorine? So this is fluorine. I've established here that atomic number is the same as proton. So atomic number is the same as proton and the same as electron. For an atom, as long as it's not an ion, it's not a charged particle. If it's an atom, number of proton, number of electron, and the atomic number are one and the same. So if fluorine has atomic number 9, it therefore means in the nucleus of this atom, I only have what? 9 protons. 9 protons. Now, a sodium atom forms a sodium ion. Describe in terms of electrons how a sodium ion is made from a sodium atom. Now, ions are made when an atom includes or gains electron or gains an electron. If an ion loses or gains an electron. If it loses an electron, it's going to form a positive ion. Positive ion. If it gains an electron, it's going to form a negative ion. So sodium has an electron of 281. If the sodium loses electron, that means it becomes 28 because it has lost an electron. Then it's going to have Na plus to indicate that it has lost 1 electron. So if I have things like calcium 2 plus, this 2 plus indicates that it has lost 2 electrons. If I have chlorine minus, it means that this chlorine ion has gained 1 electron. So in terms of electron, because they said we should describe in terms of electrons. So I will basically say that sodium ion is made from a sodium atom because what? Lost an electron. It lost an electron. Now let's move on. Now this question has to do with density. Density falls both under your physics component and as well as your chemistry component. Oh, okay. Now, you are given some information about some property of group 1 elements, and you have to describe the trend in boiling point as you go down group 1. We are not yet at density. We want to describe the patterns that we could have in the periodic table. We want to look at if I was given melting points that are alkali metals, trends in group 1, that is alkali metals. What are the trends that I could have? I have the melting point, the boiling point. So the question is, what happened to the melting point of alkali metals as we go down? What happened as we go down the group? That's what we want to look at. What happened as I go down the group? Okay. So the first thing is that we discover that the melting point decreases. So if the melting point decreases, this 180, 98, 63. So if you want to describe, okay, boiling point as well, 1342, 883, 759, 688. So just say it decreases. Okay, just say that it decreases. And we can also say that it reduces. All right, those are some of the terms that we can, okay? Or we can also say that it gets less. It gets less as we go down the. Which property does not show clear trend? Which property does not share a clear trend? I've mentioned melting point initially, that it reduces as we go down the group. Let's look at density. 0.53, that is an increase, then it decreases again, then it increases again. Let's look at the atomic radius, 145, 180, 220. So that increases down. So this does not follow a particular trend. That's density, because it does not follow a particular trend. It increases, decreases, and increases. So there is no particular trend. Why for this one, it decreases all along. This one decreases as well for boiling point. Atomic radius increases. All right. Now we have to predict the melting point of rubidium. We have to predict the melting point of rubidium. The melting point of rubidium, since we know that melting point decreases, so we must have a value that is less than 63. A value that is less than 63. So any value between, from 50, because we look at the difference between 98 is like more than 10. So that means if you look at 180 to 98, so any value between 50 to 20 degrees Celsius work for you. Any value, okay, between 50 to 20 degrees Celsius work. Then we look at, describe the change in reactivity of the element as we go down group 1. Group 1 element, if you move from lithium even to francium, we discover that even in the reactivity series, that in alkali metals, group 1 elements, their reactivity increases as we go down the group. That is why francium is the most reactive alkali metal. It's the most reactive alkali metal. So change in reactivity, though, is not on your table, but it's part of the trends for group 1. So reactivity increases down the group. As we go down the group, reactivity increases down the group. Now, this question has to do with Earth and tectonic plates. So the drawing shows the position of Africa and South America on the Earth. South America here, and of course, Africa here. Scientists think that these two continents are on separate tectonic plates. What is a tectonic plate? For us to answer this question, we must have the understanding of the structure of the earth. If you look at the structure of the earth, you have the crust. Underneath the crust, after the crust, you have the mantle. So you have the crust, you have the mantle, and of course, you have the core. Though the core can also be seen as inner core and outer core. So I can have an inner core, basically, and have an outer core, but we can say that as the core. Now, the crust and the mantle, especially the upper mantle. So if I have the crust and the upper mantle, they make up what we call the lithosphere. They make up what we call the lithosphere. All right. So this lithosphere represents the lithosphere represents, a part of the earth crust, but not just the earth. They ask me what earth crust that is floating on the mantle. So piece of the earth crust is a piece of the earth crust, a piece of the earth crust, a piece of the earth crust, okay, floating floating on the mantle, okay, that can flow, okay, which can flow or which move and which move around, okay. So you say that can flow. So I have the crust on the mantle. The mantle, remember, contains magma, which is a semi-liquid, okay, is a semi-liquid. So that magma, that mantle can flow. So as a result of that, the crust is on it. Both of them together with the upper mantle form the lithosphere. So a tectonic plate is a piece of the earth crust floating on the mantle, which moves around. All right. Scientists also think that South America and Africa were once joined together many millions of years. They use the diagram to explain, to explain why scientists think that the two continents were once joined. Okay. Now, how do we explain this? All the continents have what we call jigsaw appearance. Jigsaw appearance. And what does jigsaw appearance mean? The word jigsaw appearance means that the continents are aligned in such a way that they can fit into each other. If you look at these edges, it looks like it was detached from exactly this place. So if I join them together, it can fit into each other. Okay? So those are the evidence jigsaw appearance. So I can see that the continents have a complementary shape. Okay? They have a complementary shape, complementary shape that fits together, complementary shape together. Or I can say that there is a jigsaw appearance, okay, that can fit together. There's a jigsaw appearance that can fit together. Almost exactly. Almost exactly. So if I put this in, if I look at the continent, I will have the same scenario. So complementary shape that fits together. Also, you were giving, this is still a further question on tectonic plates. This is a model. We are to complete these sentences about this model. Okay, so the tectonic plates are represented by, what do we use to represent the tectonic plates? Looking at this, what do we use to represent the tectonic plates? Okay, remember that we said tectonic plates are a piece of the earth crust that is floating on the mantle. Okay, by what we call a convection current. Okay, so if you look at this, the earth crust here is the plastic blocks. So the plastic blocks, okay, represents that. Okay, what the water moves in a cycle. Okay, the water represents what? What is this water representing? Of course, remember in the last one that we solved, we said that piece of the earth crust floating on the mantle, floating on the mantle. So therefore, It therefore means that the water represents the magma mantle, because the magma, the mantle is made up of the magma. So the magma or the mantle. The water moves in a circle. We have this circle of the movement. We're asking, what does this represent? This particular, what does it represent? This. So basically, that represents convention current. You say convention current. Convention current. Okay, you can put that, but the word convention is enough. Okay, convention current. Now, what does the Bunsen burner represent? So this is basically like Bunsen burner simply represents the core. It represents the core, which is the source of heat for the earth. Okay, so thank you for for the listening to this lesson, which covers basically for the paper 1 of the sample paper 2020. So watch out for paper 2 in our next series. Thank you. If there's any question you would love to ask me, please drop it in the comment section.